Okay, so in this problem here, we have a road A, and then we have a highway here. On the highway, there is a town B, and I'm told the shortest distance to the highway, so the right angle, is 5, and that the distance from A to B is 13 kilometers. These are all in kilometers. And then what happens, and this is where it starts getting confusing, is they wish to make an access road to the highway, a straight road at some point J. I don't know why they don't go straight there, but they're making it J. And then they go along and define that theta is from AJ to JB. So here is theta. And we know that the speed limit here is 70 kilometers per hour, and here is 110. Now, by Pythagorean theorem, I know that this distance from, let's call it, I don't know, C to B is 12. And if you're not sure, just A squared plus B squared is C squared. Just try it out and you get 12. So if I call this distance D between J and B, then this distance here is 12 minus D, just to set up some parameters here. And so we want the time taken in terms of distance from J to B. We're looking for how long is it going to take, to go from Alphaville to J to B. So that whole distance there. So in order to find the distance, I know that distance is equal to the speed times time, but I'm looking for in terms of time. So time is equal to the distance over the speed. So I need to find this distance divided by 70 and this distance divided by 110. So to find this first distance here, I know that AJ squared will be 5 squared plus 12 minus D squared. And so if I square root that, that will give me AJ. And then I'm going to have D. So the total distance, the time it takes in terms of distance is going to be the square root of 5 squared plus 12 minus D squared over 70 plus D over 110. And that will be the total time it takes to go from A to J to B, and so on. Okay, so that's A part. That's the easier of the two parts. Now we're going to move to B part. So let me erase a little bit here. So now when I move to B part, now I want to make sure we're clear. My answer is different than the one they have in the back of the book, because I think they changed where theta is for their answer. I think they put theta here. But I'm going to take you through my problem here. With this maintaining being theta, it gets a lot harder actually than if this is theta. So if this is theta, I also have alpha there. And theta is equal to 180 minus alpha. And so basically what I'm going to do is I'm going to do things in terms of alpha, then convert it to 180. So if I'm going to find the distance, I need to find AJ in terms of alpha, and then JB in terms of, I need D in terms of alpha, or theta rather. So if I look at this first triangle here, I know if I have alpha, I know that AJ, I know 5 over AJ is equal to the sine of alpha, because it's the opposite over hypotenuse. So AJ is equal to 5 over sine alpha. And then what I can say is, I can say that sine of, let me say that correctly. So I know that alpha plus theta is equal to 180. So if I want to get rid of alpha, alpha is equal to 180 minus theta. So I then can say 5 over sine of 180 minus theta. So there's the first part. Now, if I want to get fancy and get rid of the 180, recognize that here is theta. This is 180 minus theta if I also have this being theta. This is sine, and so this is actually equal to 5 over the sine of theta, to tidy up a little bit. That's the AJ part. And so the time will simply be this distance of AJ times 1 over the rate. That's going to be the time that it takes to get this part in terms of theta. Now, to get this portion here, what I'm looking for is d, but there's d is also here. So I can also say that the tangent of alpha is equal to 5 over 12 minus d. And so 12 minus d is 5 over tangent alpha. Solving for d, I know that negative d is equal to negative 12 plus 5 over, and I'll replace my, this is tan 180 minus theta. And so d is equal to 12 minus 5 over tan 180 minus theta. To tidy up the tangent one, if this is theta, here is the angle of 180 minus theta, that's theta. I know that tangent is the opposite over the adjacent, opposite over adjacent. That ratio is going to be the same, except this value here is negative. So this is equal to minus tan of theta. And so if we finish this off, what I can say is that d is equal to 12 plus 5 over tan theta. So when I put this all together, the time, this is from a to j, plus 12 plus 5 over tan theta, divided by, or multiplied by 1 over 110. And this here is going to be the time in terms of theta. The answer book refers to, it changes for whatever reason without being clear, that being theta. If you choose that to be theta, then you'll get the answer that's in the answer book. I hope that clarifies it. It is quite challenging to put it all together, but you guys can do it.